Find the point on the curve y equals square root of 3x plus 2, which is closest to the point 50. So down here I've graphed on Desmos the curve y equals 3 square root of 3x plus 2. And we're saying what point on this curve is closest to the point 50? In other words, minimum distance, right? In other words, it's not some point over here, that would be further away, or some point up here, that would be further away. It's some point right around this, I don't know exactly where. But that's going to be the minimum distance from the 0.50. That's what closest means, right? Um, it's closest means minimum distance. Okay. So we know so here's the equation. We did this in another problem, the setup. We found the equation for the distance formula between the 0.50 and some random point xy on the curve y equals square root of 3x plus 2. So now that we have that, we're going to finish this problem. So we're saying, okay, so here's the distance formula. And if we want to find the minimum distance, then we want to oops, minimize d, which equals the square root of x minus 5 squared plus 3x plus 2. Want to minimize that. Well, how do we minimize something? Well, we take the derivative and we set it equal to 0, right? Because when the derivative, the slope, is 0, that's when you find your peaks and your valleys. Like on a roller coaster, when you're at the top or the bottom, your slope is flat, your derivative is 0. That's how we find mins and maxes. So, but before we do that, let's notice the hint. Hint, to make the work easier, first find the d of x squared by squaring both sides, and then just find the minimum for that function, since the same x value will make both d of x and d of x squared minimal. What am I talking about there? Let me show you. Down here, I've got an example kind of written up for you. So here's a table x value. Here's the distance formula we were just looking at. And I just picked some kind of x values sort of at random, nothing special about them. And I just plugged in 4 right there for x. I worked it out and it got square root of 15. Then I plugged in 5 and got square root of 17, plugged in 6, got square root of 21. Which one of these is minimum? Well, this one is the minimum. This is the lowest one, right? Okay, and that happens where at x equals 4. But then over here, I went ahead and I took this distance formula and I squared them. I squared all those numbers. That just removed the root. So which of these is lowest? Well, obviously the same one. This is minimum, right? So in both cases, that goes with x equals 4. Do you see my point? If you find which of the d squareds, the distance squareds, is lowest, that's going to be the same one for which the regular distance is lowest, same x value. See that? So now why would you want to do that? Well, I want to get rid of that root. Take the derivative with the root. Roots are a pain. I mean, we could do it. It's not the end of the world. But if we can do something a lot easier using logic, that's really what math is about. Use logic to find an easy way. Then let's do that. So it's saying, look, just square it. Get rid of that root. So I'm just going to take d squared. So I'm going to square this side and square that side. So what do you get? Well, it's just going to remove that root, isn't it? And so we'll just get x minus 5 squared plus 3x plus 2. And now we will minimize that. Just minimize d squared. It's going to give you the same x value as if you minimize the original d as we saw. Okay, so let's do that. So how do you do that? You take the d squared equation and you take the derivative and set it equal to 0. All right, let's do the derivative here. How do we do it? Well, uh, down comes the 2. Here, let me change my so 2. X plus 5 to the 1, subtract 1 from the power. Plus root of 3x is just 3. 2 just goes to 0. And then we what? We set that equal to 0 because we want to know where the derivative is 0. That's where the peaks and valleys are. Okay, so let's a nice easy equation. No more roots or anything. So 2x minus 10 plus 3 is 0. 0. And then that's 2x minus 7 is 0. Minus 10 plus 3 is minus 7. Jump this to the other side. 2x is positive 7. Last step, divide by 2, divide by 2. X is 7 halves, or the decimal would be 3.5. So there's the x value that makes minimal distance. And that's the x value they got right there to make minimal distance. There it is. Right there, 3.5, that's our x value. That's the point, and it looks like 3.5, doesn't it? Like round, pretty close. See, it's about 3.5, that x value about 3.5. The dot's right there. That's going to be where the point, about right there at 3.5, that's going to be the point close on the curve, closest to the point 50. Very useful for all kinds of applications. For military, targeting things, medical, they target things with lasers and different things inside our bodies, engineering, sports applications, tons of applications where you want to find the closest point on some curve or line or whatever to some other point. Find that point. We just did it using calculus, minimal distance. There we go.